In this video I'm going to be showing you how to use law of cosines to solve for oblique triangles. Those are triangles that are not right triangles. So in some cases we can use what's called the law of sines. So if you haven't already, you should watch that video first. And in cases where we cannot use the law of sines, we can use this other law. It's called the law of cosines. And for this, we got three fairly long formulas here. One of them looks like this. So in general, the lowercase letters are going to symbolize your side lengths, and this capital letter is going to be an angle measurement. So right now this equation is set up to solve for side A, but sometimes you're going to want to solve for angle A, and so usually they don't give you the equation in terms of angle A. So I would suggest taking all three of these equations, and I'll give you the other two in a sec, and solving them in terms of angle A. So I'm going to show you how to do that with this one equation here. In order to solve for cosine of A, we're going to subtract b squared and c squared from both sides, so that I get on this side that so far. We still have negative 2 times b times c times the cosine of A on this side. So because everything on the right side is now being multiplied, to undo it or get rid of it, I would divide. So if I divide both sides by negative 2bc, I can get that cosine of A all by itself. So this all goes away. And now we're left with the cosine of A is equal to this ratio on the left here. And that would be a decimal value. But that still doesn't give us the measurement of angle A. So one more step before I do that, though, is to take this and make it in terms of a positive equation. So because I'm dividing by negative 2 here, I'm going to get rid of that. Or really, I'm going to divide everything by negative 2. Or sorry, negative 1 here. And make everything the opposite of what it looks like right now. So I'm going to take negative b divided by negative 1. That becomes a positive b squared. I'm going to take negative c squared and divide that by negative 1, and that gives me a positive c squared. But because this a was already positive, and I divide it by a negative, now it becomes a negative a squared. And on the bottom, I multiply by negative 1, and that becomes positive 2 bc. So now everything is in a more positive term here. And then, so this still is going to be a decimal value if I was to evaluate it. And so to get an angle measurement, we want to use the inverse. So if I do the inverse cosine of all of this, that will equal the measurement of angle A. So if you do that with all three of your equations and then have 6 of your equations there to use at any given time whenever you need them, it's a lot more helpful, because in general any book I've ever seen is only given a law of cosines in terms of side lengths. And then so if you set up all three of those equations in terms of your angle measurement, it's a lot easier to use, and you can just plug things in as you need them. Alright, so the last two equations are just in terms of side B and side C. So I'll write those down real quick, and then we'll do a couple examples here. So the next one would be b squared is equal to a squared plus c squared minus 2ac this time, cosine of angle B now. And the last one, c squared, is equal to a squared plus b squared minus 2ab times the cosine of angle, cosine of angle C. That's what we're doing. There you go. That should not be a negative sign right there. There you go. So there's all three of our equations. And if you take each of those, solve them in terms of your angle measurement, it makes life a lot easier. Alright, let's do some examples here. Let's say we're given a triangle. It looks like so. So here's a case where we have side, angle, side. So if you watched the last video, you know that we do not have a ratio of A or B or C. So that's a good clue to let you know that you're probably not going to use law of sines, you're going to use law of cosines. Law of cosines is helpful when you know at least two sides. Right, so what we're going to do is we're going to try and solve for the side that we know an angle for. So because we know angle A and we're missing side A over here, we're going to solve for side A. So we're going to use the A equation. It's a squared equals b squared plus c squared minus 2bc times the cosine of A. So we're going to substitute into our equation what we know and solve for what we don't know. So we know that b is 20, we're going to square that. We know c is 30, we're going to square that. And we're going to subtract 2 times 20 times 30, and we're going to multiply by the cosine of 60 degrees. Couldn't fit it there, but it should all be one line. So moving down here, 20 squared is 400, 30 squared is 900, 20 times 30 is 600 times 2 is 1200, and the cosine of 60 degrees is 1/2 or 0.5. So keep solving for what you know. We're going to simplify our addition here. It's 1300. Half of 1200 is 600. Do the subtraction. We get 700. And now to solve for A, the last step, to get rid of a square, you square root. And so A is approximately 26.5-ish. Alright, so now we know what the side length of A is, and we can set it up to solve for our two missing angles if you wanted to. So in order to do that, hopefully you have your equations set up in terms of your angle now. It makes it a lot easier to solve for your angle. And really, I mean, you can use your law of cosines to solve for both your missing angles, but a nice little shortcut would be to just solve for one of your angles using law of cosines, and then just add up what you know and subtract from 180 to get that last angle. You don't need to use law of cosines for all three angles. So I'm going to pick one angle. I'm going to choose B just because it's next alphabetically. So when we set up our equation, law of cosines in terms of angle B, it's the inverse cosine of a squared plus c squared minus b squared all over 2ac. So we can substitute things into this equation and it simplifies our life a little bit. So a squared, we now know, is 26.5. And we're going to add that to c squared, which is 30 squared, and subtract 20 squared all over 2 times 26.5 times 30. So if we evaluate this and get that decimal value, and then take the inverse cosine of that. And then we get our angle measurement, which is approximately 40.9 degrees. And now that we know two angles in our triangle, add up what you know and subtract it from 180. And so we find out that we're missing approximately 79.1 degrees. So we were able to solve this oblique triangle using law of cosines. Slightly different than law of sines. Let's do one more example here. Let's set up another triangle. Let's make that C, sorry. This time we know all three sides and we're missing all three angles. That's always a good clue that we're going to use law of cosines. If you don't know any angles and you know all three sides, automatic law of cosines to solve this triangle. So now you have a choice. You can just pick an angle to solve for. It doesn't matter which one you pick. I'm going to choose, let's do B. So I now set it up in terms of angle B. I already have that equation ready to go. Again, having that equation already set up and ready to substitute saves a lot of time. So now we substitute what we know here and simplify. And if you simplify this ratio, hopefully you get negative 91 over 208. Now I can take the cosine of this, and that would give me a decimal value. That's not going to give me an angle measurement. So what we want to do is take the inverse cosine of this ratio, and that will give me my angle measurement, and it's approximately 115.9. So now we know one angle. Need at least one more before we can take a shortcut here. So I'm going to set up law of cosines in terms of angle. In terms of another angle. It doesn't matter which one, either A or C. So I'm going to solve for angle C. I'm going to set it up. The inverse cosine of my equation would be a squared plus b squared minus c squared all over 2ab. When I substitute, I get approximately, what was it, 288 on the bottom and 219 on top. So if I take the inverse cosine of this ratio, I get my angle measurement, which is approximately 40.5 degrees. And now I can take my shortcut because I know two angles in a triangle. I'm going to add up what I know and subtract it from 180, and I get my last angle, which is about 23.6 degrees. So again, we used law of cosines to solve this oblique triangle. This time we knew three sides and we knew 0 of our angles, and we were able to solve for all three angles. Alright, so good luck using law of cosines to solve oblique triangles. And really the trickiest part is recognizing whether or not, rather whether you have to use law of sines or law of cosines based on the information that you're given. Alright, see you in the next video.